Hi there, this is a Algebra 2 video. It is Chapter 4, Section 3. We are solving quadratic equations now by factoring. We've done solving by graphing and using the calculator. And now we'd like to try a different technique, and that is to solve by factoring. But before we begin with factoring, we want to first talk about factoring is basically involves products, multiplication. And so one of the things that we do before we learn how to factor is distribution. And FOIL, which we've done in the past, is one of the methods that we use for distributing when you have a binomial. A binomial means that you have two terms. So basically I have a binomial being multiplied by a binomial. Terms are separated by addition or subtraction. So for example, x squared plus 3x plus 5. This is three terms. They're separated by this addition symbol. So in other words, 3 and x are not separate terms because that's multiplication, that's tying them together. And multiplication and division do not separate terms, only addition and subtraction. So here I have subtraction, so that separates these two into two terms and two terms. So that's why we call it a binomial. And so basically what we have is a binomial being multiplied by another binomial. And when you have that situation, you need to distribute. In other words, x needs to get multiplied to the x and the negative 2. And the 6 needs to get multiplied to the x and the negative 2. And that's basically what we're doing. But FOIL is a nice way to help us remember how to do that and not forget one of the steps. There should be 4 terms and the first step of the FOIL process, and then after that you can combine like terms so that you can get a trinomial. When you multiply two binomials, most of the time you're going to get a trinomial. So F stands for first, O outer, I inner, and L last. So first means that you're going to multiply the first term by the first term of each binomial. So this is first times first, and x times x is x squared. Then you're going to get the outer. And outer means to multiply the outer term by the outer term. So these are the outer terms. And x times negative 2 is negative 2x. And then the I stands for inner, which means you're going to multiply the two inside terms, which are going to be these inner ones. So we get that, or you could even, let's do it this way. And so you get negative 6 times x, which is negative 6x. And then we have the last times last. L stands for last times last. So you want to take the last term times the last term. So negative 6 times negative 2, which is positive 12. And see how you have 4 separate terms. But you will notice that in the middle here we have two terms that both have x in them. So we can actually combine those into one. So our final answer would be x squared, negative 2x and negative 6x is negative 8x, and then plus 12. And that would be our trinomial. Okay, so you can see that this is basically what we would call the factored form. And so our goal in this lesson is going to be that they're going to give us this form, the standard form, and then we are going to factor it into this form. So most of our answers are going to look like this up here. But I wanted to remind you guys of the FOIL method before we continue, because foiling will be one of the ways in which we can check that our answers are actually correct. So, example 1 says, write a quadratic equation in standard form with negative 1/3 and 6 as its roots. When it says that negative 1/3 and 6 are the roots, what it's really saying is that the solutions are x equals negative 1/3 and x equals 6. Now, if you take and want to get rid of the fraction here in this first case, we can multiply both sides by 3, and that'll give us 3x equals negative 1. And then we can add 1 to both sides, and you will get 3x plus 1 equal to 0. Over here, we don't have any fractions, but we can move the 6 to the other side. And this might seem a little strange because it kind of does seem like we're going backwards. Normally, we want to arrive at the solution. But in this case, they actually gave us the solution first, and we're working backwards to try to get the equation. So now we know that these two are the factors. So now we want to multiply those like we did in the previous example with the FOIL method. We want to multiply 3x plus 1 and x minus 6 using the FOIL method. So FOIL tells us again to go first times first, so 3x times x is 3x squared. Outside times outside is going to be 3x times negative 6, so negative 18x. Inside times inside is 1 times x, which is just positive x. And then last times last is 1 times negative 6, which is negative 6. Notice also, I don't know if you guys have seen this, I always think it's really funny. Once you've done all the arrows in the diagram, this actually kind of looks like a happy face, where you've got like the eyes and like this overlapping eyebrows, you got a nose and a mouth, and it kind of looks like a little person. I don't know if you noticed that here too. But anyway, just a way to help you remember what multiplies with what. And so I can see here that this is, again, like terms. So I get 3x squared. Negative 18 plus 1 is negative 17. And so this is my quadratic equation, which is in standard form. And it's going to have roots negative 1/3 and 6. So that is how you do that. And so I want you to try this one on your own. And then we'll move on to the zero product property. So here we have the zero product property, and it's exactly that. It's basically a property that helps us determine what A and B should be when it's supposed to equal 0 when you have a product. So I hope that this makes sense. I'll go through it with you very briefly here, but basically it says if you have a product, if you have A times B, and that product is equal to 0, then only 3 cases can be possible. Either the first letter is 0, because then 0 times B would be 0, and it would equal 0, so you'd be good to go. If it's not that A is equal to 0, then B could equal 0. If B was equal to 0, then again you would have A times 0, but anything times 0 is 0, so it would still equal 0. Your third option, which doesn't happen very often, but it could happen, is what if they were both 0? Then obviously 0 times 0 would be 0, and the equation would equal 0. So whenever you have a product with 2 items, or even if it were 3 items, as long as one of the items is 0, then the whole thing will be 0, because 0 has that special property of 0 times anything is 0. So to give you an idea of how that plays out in our case, we have a product here, kind of like what you've been seeing happen in the previous examples. We have a product where we have a binomial and a binomial. It doesn't have to be a binomial, but you have a product here, and I've kind of color-coded them kind of like the theorem. So you can see here's my A and here's my B. I have a product and I want to know when it's going to equal 0. Well, this will equal 0 as long as x plus 3 is 0. If this right here equals 0, then 0 times x minus 5 will be 0. Or x minus 5 could be 0, and then 0 times this would be 0, or they could both be 0. All right, so let me tell you what I mean. For example, if x equaled negative 3, and we're just using some mental math here, then I would plug negative 3 into the x value, and I would get negative 3 plus 3, which is 0. Over here, I'd get negative 3 minus 5, which is negative 8. So this term is 0 when x is negative 3, but this one is not. But that doesn't matter, because when I multiply the two numbers, since this is 0, 0 times negative 8 will be 0. So one of my solutions for this equation is that x equals negative 3. In a similar fashion, what if I chose x to be 5? If x equals 5, then in this factor, 5 minus 5 would be 0. In this factor, 5 plus 3 is not 0. 5 plus 3 is 8. But again, 8 times 0 is 0. So both 5, the number 5, and the number negative 3 will produce a case where this product will equal 0. And that's kind of how the zero product property works. And that's what we use when we solve equations by factoring. Our first step is to take the standard form, factor it into this form, and then solve each factor for 0 to get our solutions. But we're going to start here with an example. And you can see that in the example on the same board. I have my example will be done up here. I'll do this for you. And then I'm going to have you guys try these A, B, and C in the do-it-yourself question. Okay? So in this case, we want to try this whole thing about factoring. And when you're factoring, what you're looking for is the greatest common factor. I think that all of you understand pretty much how a factor tree works. But I want to just remind you, for example, if you wanted to do a little factor tree for the number 15, you would do something like this, and then you go 5 times 3, and then each branch of the tree gets multiplied. So when we see the 5 and 3 here, we don't think 5 plus 3. We know that it's multiplication, that you're multiplying. This is 5 times 3, which will equal 15. So what we want to do is we basically want to do the same thing here. We want to break this up into 2 pieces, where when we multiply the 2 pieces, they will equal the top. So I basically want a factor tree, basically, kind of like this, where I have 2 branches, and when I multiply the 2, I get back to the original. So in order to do that, what we look for is the greatest common factor. What number goes evenly into both 16 and 8? Well, that number would be 8. 8 goes into 16 twice, and 8 goes into 8 once. So you get 8. The other thing that they both have in common is they both have the variable x. And when it comes to variables, you always want to take out or factor out the variable that has the smallest exponent. So they both have an x, but this one has an exponent of x to the 1, and this one has x squared. Since one is smaller than x squared, you want to pull out the x, okay? So we get x. Then we have over here our other branch. We have to ask ourselves, 8x times what will give us 16x squared? And that would be a 2x, because 8x times 2x is 16x squared. Then you would say 8x times what is 8x? And you would put a 1, because 8x times 1 is itself 8x. So now you have the 2 branches, and basically your answer would be 8x times 2x plus 1. And you can do a really quick check to see if you got it right by distributing to make sure that this is the exact same thing as the original. Because remember, the factor tree says that when you multiply the 2 branches, you should get back to the original. So we go 8x times 2x, which is in fact 16x squared, and 8x times 1 is 8x. And so we did it right. So now I'd like for you to try A, B, and C here for do-it-yourself number 2. And then we're going to move on, and although you might think this is kind of crazy, I just want you to be open-minded and kind of go with me here as we learn how to factor trinomials. One of the things that you'll notice about example 2 is that you only had 2 terms. We talked about that earlier. This only has 2 terms. A has 2 terms, B has 2 terms, C has 2 terms. And those are simpler problems. But now when we go to our next example in a bit, we're going to start dealing with quadratics that have 3 terms. And how does that pan out? But again, remember that we are still trying to do a factor tree. So I'm going to write my function over here again. And we are looking for 2 factors, 2 branches, that when we multiply them will equal back to the original. But this time we have it in the standard form, which is the ax squared plus bx plus c. All 3 terms are present. And so I want to show you a technique on how to factor these trinomials. It is unique, not to me, but it's not in your book. So if you are looking through the book and trying to follow the way the book is doing it, you're welcome to do that, but I will tell you that it's a lot more complicated than the method that I'll be showing you on the board. Not to mention that whenever I go over questions on the board and when you get into other, like, pre-cal and AP-cal later, I'm always going to factor this way, and so it's important that you know how this works as well. So this little device over here is basically an organizational device. It just kind of helps us keep everything organized. when you are factoring a trinomial, it can get kind of funny. So I really just need to show you how to do it, and then I will FOIL it so you can see that it actually does work, and then we'll do another example afterwards as well. Okay, so right now just try to, I'm just going to go over what this over here is. So basically what we're doing here is we have this kind of a grid, and there's kind of 4 quadrants in here. So the 2 quadrants that are on the left are where we put the factors of a, you know, the a term. Now remember that a is just the coefficient, so I don't need the x's, I just need the a. So in this case, our a is 1x squared. So when you think about a equals 1. So what are the factors of 1? So that's pretty simple. Our factors of 1 are going to be, and I'm going to put my little grid over here, the factors of a, in this case, are 1 and 1, because 1 times 1 is 1. If this number had been a 2x squared, then you might want to put a 1 and a 2. Or if it was a 6, you might want to put a 2 and a 3. So it just depends on what the a value is. In this case, the a value is 1. The only factors of 1 are 1 and 1. So on the left side, you put the factors of a. Then on the right-hand side, top and bottom here, we put the factors of c in that position. So factors of c would be factors of 10. Now for 10, you do have some options, because you can do 5 and 2, or you can do 10 and 1, and that's pretty much about it. So those are the factors of c. And we're still not done. Sometimes you might put numbers here, and then later you might have to erase them because they didn't work. Just because 5 and 2 are factors of 10 doesn't necessarily mean it's going to work. So, for example, I actually want to not do that right now, because I kind of want to show you what would happen if you had the wrong numbers. So let's say that I did 10 times 1 is 10. So these are the factors of 10. And 1 times 1 is 1. Those are the factors of a. So everything's great. Well, the other thing that you'll see right here is these little arrows. What you're supposed to do is you're supposed to multiply along the diagonal. So 1 times 1 is 1, and 1 times 10 is 10. And then it says multiply along diagonals. Sum should equal the b term. So when I add the diagonals together, so I multiply this diagonal, multiply that diagonal, I add them together. In this case, I get 11. But the b value is 7. So this is not the right combination. So this combination has to equal 7, or else it's not the right combination. So that's why I'm showing you, like, you can do this with different numbers, and you can try different numbers until you get the right numbers. So 10 and 1 were not the right numbers. So now I go back to trying the 5 and 2. This time, when I multiply along the diagonal, I get 1 times 2 is 2, 1 times 5 is 5, and 5 plus 2 is 7. And this time, b is 7. So now I know that I do have the right combination of numbers. Once you get your numbers to be accurate in this diagram, then you have that this side is the variable side, and this side is the constant side. So our variable is x. So basically what that means is this is 1x, and that's 1x, and this is just 5 and 2. There's no x attached to it. And then it says the answer goes across. And that means that your answer is going to go this direction. So my answer, my 2 branches, are going to be 1x, and then positive 5 means plus 5, that's one branch. And then the other part of my answer, the second branch, is on the bottom. So 1x, and then a positive 2. Those are my 2 branches that will complete my factor tree. So my answer will be x plus 5 times x plus 2. And you're probably thinking, what? How does that equal the, x squared plus 7x plus 10? Well, we can check it very easily by FOILing. We can say first times first is x squared. Outside times outside is 2x. Inside times inside is 5x. And last times last is 10. We combine our like terms, and we get x squared plus 7x plus 10. And there you go. So this product does in fact equal the original problem, so it is factored correctly. And that is how you factor using this method over here. Now I know that this is the first time some of you have seen this, so it might take a while to get used to, We did use it in Algebra 1, but again, if I didn't teach you Algebra 1, then you probably don't know how to do this method. But we're going to do it again in example 4. And no, I did not skip, I mean, I did skip example 3, but I purposely skipped it. And I skipped it for a good reason. The way that I teach it with this different method, I want you to learn this method first, and then we're going to use this method to do example 3 afterwards. So right now, just go with me to example 4, and we're going to do our little table. Again, in part A, we have 1x squared, so we're going to put a 1 and a 1 here. Factors of A go on the left, and when you have a 1, it's pretty simple. Then we want factors of 20, and with the factors of 20, you could do things like 10 times 2, 5 times 4, and so I'm not going to do 10 times 2 because I know that 10 and 2 is going to add to 12 or 8, and I want a 9. So I'm going to put a 5 and a 4 here. And when I multiply my diagonal, just to make sure everything's okay, 1 times 4 is 4, 1 times 5 is 5. And when I add them together, I do get 9, and that's B, so it works. Once I have the numbers correct in here, remember that this is the variable side, this is the constant side, and my answers go across. So this is going to be 1x plus 5, and my other factor is going to be 1x plus 4 equals 0. So now we factored it. Okay, but remember that we just previously had learned about the zero product property. So once we have it in two factors like this, we know that to solve the equation, as long as one of the factors is 0, then the whole thing will be 0. So at this point, we separate the two and solve them separately. You could use mental math, but that isn't always possible. So I want to show you how you do it algebraically. We separate each factor. We make x plus 5 equals 0 by itself. We make x plus 4 equals 0 by itself. And then we just solve them like we would solve any normal equation. So I subtract 5 from both sides, and I get that x equals negative 5. Over here, I subtract 4, and we get that x equals negative 4. And those are my two solutions, x equals negative 5 and x equals negative 4. And it is true that if I plug in negative 5 into this equation, it will work. Negative 5 squared is 25. 9 times negative 5 is negative 45, and then plus 20. So we know that 25 and 20 is 45, and then minus 45, and you get 0. So see, it worked. Same thing happens with negative 4. Negative 4 squared is positive 16. 9 times negative 4 is negative 36, and then you have your plus 20. And again, 16 and 20 is 36. And then you subtract 36, and you in fact get 0. So our two solutions actually worked. Okay? So again, you want to first do the little table thing over here, factor it, separate it into two separate factors, solve those individually, and these are your answers. Now you can check your answers if you like by plugging them into the original, but in this case, they didn't ask us to, but I wanted to so you can see that it actually works. So our solutions, just to be clear again, are negative 5 and negative 4. So now we try that process all over again, and this time we have a little bit more of a tricky problem because now we do have something in front of the quadratic. We have a 6. So if you have a 6, you can do 6 times 1, or you can do 2 times 3. Those are the two options that you have for a 6. And then you have 20, and for 20 you can do let's try 5 and 4, and let's try 5 and 4 first. Okay, so I'm trying 5 and 4 in both scenarios, okay? So in this case, I get 6 times 4 is 24, and 1 times 5 is 5, so I get 29. So that's not going to work. The other thing that you have to consider is that this is a positive 20, and this is a negative b. So the only way for you to do that is for you to have two negatives. So you can get negatives here. Okay, in other words, I could do negative 5 times negative 4 is positive 20. So that would work. You can use negatives in your combinations. But then that would be negative 24 minus 5, and there would be negative 29. And b is not negative 29. So this combination won't work. But you can also switch them. Instead of 5 and 4, what would happen if I made it 4 and 5? Does that affect anything? We're going to find out. 6 times negative 5 is going to be negative 30. And then 1 times negative 4 is negative 4, and you get negative 34, which again is not B. So this combination will not work. So we don't want that combination. So now we're going to come over here, and again, we want to remember that we need to make these negative if they're going to work. So 2 times negative 4 is negative 8. 3 times negative 5 is negative 15. And then negative 15 minus 8 is going to be negative 23. And so this time we got lucky, and that's the magic combination, because 2 times negative 4 is negative 8, and 3 times negative 5 is negative 15. And when you add the two together, you do in fact get negative 23. So now that we have the right combination, we can put our branches together. Remember that this is the variable side, so this is 2y, and then minus 5. And my other branch is 3y minus 4 equal to 0. Okay? And so now we can actually solve the equation by separating them. So we want 2y minus 5 to equal 0. And then separately we want 3y minus 4 to equal 0. And then we're going to solve by adding 5 to both sides. So you get 2y equals 5. Divide by 2. So you get y equals 5 halves. And over here you want to add 4 to both sides. So you get 3y equals 4. Then we divide by 3. And y equals 4/3. So your two solutions for this example, for part B anyway, is y equals 5 halves. And also y equals 4/3. Okay, so now I want you to try these 4 examples. And then we're going to go back to example 3. This is going to be our last example. And I just want to remind you that this is the exact same thing that we've been doing before. Just want a little twist on it. Here you want to go x squared minus 64 equals 0. We want to bring the 64 to the other side. And what's going to happen here is that you're still going to have your 1 and your 1. When you get the factors of 64, you know, that's a perfect square. So 8 times 8 is 64. And when I combine 8 and 8, I get 8 plus 8, which is actually 16. So this is just a case where you end up with the same factor twice, because I have 1 and 8 and 1 and 8, so it repeated itself. And when that happens, you just write the answer as x plus 8 quantity squared. So this is just a variation of what we did earlier. So when you get the same thing twice, it doubles up on you, the b value doubles up on you, then you can write it like that. And then you have this case where you have 1 and 1, and then you have 8 and 8 because you have 64 again. But this time it's a negative 64, so one of those 8s has to be negative, so you can get a negative 64. And what's interesting about this problem is that the b value is missing. You can actually write x squared plus 0x minus 64 if it makes it easier for you. And what you want is for your diagonals to add up to 0, which they will, because positive 8 and negative 8 will equal 0. So when you have the same factors, but one's positive and one's negative, then that case is going to happen and they'll cancel out. And so now your factors are going to be 1x minus 8 and 1x plus 8. And that's it. So even though it looked like it was going to be all weird, you can still use the little grid here to help you solve this example. So now I want you to do these 3, and once you've done that, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.